So we're going to start talking about how to solve a system of equations using elimination, and this is something that you may have done before in Algebra 1. So we're going to start by just kind of reviewing how to use the elimination method when you're trying to solve a system of equations. And what the elimination method does is you get rid of one of the variables that you have in your equation, so that instead of having a system with two unknown variables, you have a system with just one. So then it's easier to solve for the one, and then you use that value to plug it back in to help you find the other missing one. So the steps to do this are to multiply one or both of your equations by a number to result in the two equations that contain opposite terms. So what that means is, let's say you have a 2x and a 3x. You would want to get 2x and 3x to have the same number in the front. So for example, they both want to have a 6x because 2 and 3 can both go into 6. Then you also want to have one of them be a positive 6x and one of them be a negative 6x, because then if you add the equations together, they'll end up canceling each other out, therefore eliminating them, and you'll have just the other variable left, like a y or whatever letter that they're using. So after you've gotten them with the opposite terms, you add the equation, you eliminate the one variable, and you solve it for the other one. After you have the value for the other variable, go back to one of your original equations and plug that value in to help you find the other variable's value. So let's look at a couple of examples here together. So this first one, I have x plus 2y equals 10 and x plus y equals 6. Right off the bat, if I notice the x's here, they're both just a plain x. They technically have ones in front, so it's like 1x plus 2y, 1x plus y. So already they have the same number in the front. It would be really easy for me to just take one of these equations times like a -1 to get it to switch signs. That way they're the opposite of each other. It does not matter which one you decide to do that to. So if you want to just take the bottom one times a -1, you can. Now you could also do this to the top one, but I'm just going to do the bottom one because it might make it a little bit easier when I go to add my terms together. So across the top, we have x plus 2y equals 10. And then on the bottom, when I multiply everything by -1, I get -x minus y equals -6. So now what I'm going to do is add these equations together. So I'm going to put kind of parentheses around this. Otherwise, sometimes the plus minus here can get lost or it can get kind of confusing. So now if I add, my x and my -x are going to cancel each other out. So they're gone. They've eliminated each other. That's the whole reason why I did that. Now for the other one, I have 2y plus a -1y. So 2 plus -1 is just going to be 1, positive 1, and then y. So you can write 1y or you can just leave it as y. Bring down the equal sign. 10 plus -6 would be positive 4. So we've already solved for one of our variables right there. So now what I'm going to do is take this value, y equals 4, and I'm going to go back up here to one of the original equations and use it now to help me find x. It does not matter which one you go back into. So I would probably pick the easier equation to work with, which for this one is going to be that bottom one. So I have x plus y equals 6. So I'm going to put in 4 for the y. So now it says x plus 4 equals 6. And now I solve for x. So I subtract 4. And so 6 minus 4 is 2. So x is 2, y is 4. Usually we like to write these as an ordered pair. X always comes first, so 2, comma, 4. So this would be the solution for that system of equations. Let's take a look at one more. If you'd like to, go ahead and pause the video here, try this one out on your own, and then when you're ready for me to go through it with you, you can go ahead and resume watching the video. So what I see first of all is that I have a 2x and I have a negative 2x. Okay, so already I have the same number in front of my x, they both have a 2, and they're already opposite signs. So this one's actually set up really nicely for me. I don't have to worry about doing anything special to these. I can just go ahead and add these two equations together. When I do that, 2x plus negative 2x are going to eliminate each other. And so now I have negative 9y plus 6y. So negative 9 plus 6 is going to be negative 3 and then y equals, I've got 34 plus a negative 28, which is the same thing if you wanted to take 34 minus 28, which is going to be 6. Then to get y by itself, I need to divide both sides by negative 3. And so 6 divided by negative 3 is going to be negative 2. So there's your y. Then just like this last problem, I'm going to take this negative 2 and come back up here to one of those equations. Now this time I don't have a super nice one like number 1 where we had just like x plus y. So I am going to have to do a little bit of work regardless of which one I decide to do here. So let's go ahead and just use the top one. So it says 2x minus 9y equals 34. We're going to start by plugging in that negative 2. So 2x minus 9 times negative 2 equals 34. So I have 2x plus 18, because double negatives there, equals 34. Then I'm going to subtract 18 from 34. So I have 2x equals 16. Divide by 2. X is going to come out to be an 8. So again, writing it as an ordered pair would say 8, negative 2. Alright, and that's where I'm going to end this video at. We are going to get started next with solving a system of equations that has 3 variables. So we're just going to practice a little bit more today with these 2 variable equations. I just want to add a quick note that if I didn't have one like this in here, but if you had a situation like if I had different numbers in front of my x's where they weren't the same number, you would have to multiply either one of the equations or both of the equations in order to get them to look the same. So for example, let's just say you had something that looked like 2x plus 5y equals 10, and you had 5x plus 7y equals 12, okay? You can notice here that neither the x's or the y's match, so you are going to have to pick like which ones you want to make match. So if I'm looking at like 2 and 5, I'm going to have to either multiply like the top by 5 and the bottom maybe by negative 2. That way I get 10x and negative 10x. I could also do that to the y's if I didn't want to do it to the x's. 5 and 7 can both go into 35. So I could take 5 times negative 7, and I could take 7 times 5, and I would get negative 35 on top, positive 35 on the bottom. It doesn't make a difference which one you choose to do that to. If I were doing this problem, I would maybe do the 2x and the 5x like I was doing it first, just because you're going to have smaller numbers there. But it really doesn't make a difference. So if you come across a situation like that, where you have to multiply both of them by something, or it could even be like instead of a 5x here, maybe it was a 6x. Instead of having to take the both equations times something, I would only have to take the top one like by a negative 3. That way it became negative 6x, and I wouldn't have to do anything to the bottom one. So I just wanted to put that out there because we didn't see one like that, and cases like that happen all the time. So you would just have to decide which one you want to get rid of, which one you think would be easier, and go from there.